Now in Unit 10, we're going to be looking at area of figures, areas that we have learned. We have learned these formulas before. In algebra, you guys covered this, pre-algebra as well. So we're going to be using them. So for example, number one says find the area of the rectangle in square units. Round your answer to the hundredths place if necessary. So the area of a rectangle, as a reminder, how do we get the area of a rectangle? We have to choose a corner. It's a 90-degree corner. The 90-degree corners are very, very important areas. One side, one side we called it length, right? Usually the long side, it's length. The short side is called width, and the area of the rectangle is length times width. So that's exactly what we're going to be doing here. So let's take a look. It's a rectangle, so I know this area, these are 90-degree angles. So first of all, let me find the area, the length of the width. So this right here, it is crooked. If it was right on the, if it was vertical or horizontal, I could count the squares in between. But what I'm going to be doing, we have learned the distance formula. So we're going to use it. Let me get the coordinates of my point S. If we're looking at the coordinates of point S are -9, that's -9 on the X and +12 on the Y. So my coordinates of point S are -9, 12. Looking at my point R, the coordinates of my point R are -13 on the X and 5 on the Y. So -13 and 5 on the Y. So I'm going to use the coordinates and the distance formula. I remember the formula. If you guys need it, let me remind you of the formula. We have the second x minus the first x. So the difference of the x's squared plus the difference of the y's. So the second y minus the first y squared. And all this inside the square root. So what I'm going to be doing is let me take a look at my x's first. So I'm thinking, okay, the difference between -13 and -9. So I can go, well, let me go -13 minus a -9 all squared plus the difference of the y's. So I'm going to go 5 minus 12 all squared. And this is side at square root. All right, so -13 minus a -9, two negative signs make a plus sign. So the distance between -13 and 9 is -4. But I'm going to write this as a +4 squared because once I squared everything, the negative goes away. Plus the distance between 5 and 12 is 7, right? 5 minus 12 is 7. It was -7, so I'm going to call this 7 squared. So I'm going to find out what's the square root of 4 squared plus 7 squared. Okay. Well, I gave you guys a calculator. I already have it here, so I'm going to type it in. 4 squared plus 7 squared. Oh, like it's a big number, right? 8.06225. Mm, I know my answer eventually had to run it to the nearest hundreds. So two decimal places. I know I'm going to be multiplying decimal places. So let me round it already to two decimal places here. Or you know what? I'll leave it there for right now. I'm just going to tell myself it is about, this distance is about 8.0622. I want to go four decimal places. Okay. I want to use my calculator in a minute, so that's why I don't need to, that's why I said it's about. I don't need to write the exact number, but let me figure out the distance of the length. So again, I'm going to use my distance between my point S and T. I see the coordinates of S are -9 and 12. Let me get the coordinates of my point T. This is by 4. So I have to do the distance of the x's, -9 minus 5 squared. The difference of the y's, so 12 minus 4 squared. I know -9 and then -5 is -14. However, I'm going to write this as 14, positive 14 squared, plus 12 minus 4 is 8. So let me call this 8 squared. And this is the square root. Okay. So let me come back to my calculator. So I have the square root of 14 squared plus 8 squared. And it gives me about 16.1245. So let me come back to my notes here. This is 16.1245. Okay, so I'm good. I'm ready to take the area of this, right? I just had to multiply these two numbers. That's why I said we're going to come back to our calculator. So that's a good thing. I'm going to grab my calculator. I'm going to tell it 8.06 22 times 16.1245. I type it in. I have to go to the nearest hundred, so 2 decimal places. So it's a 9, but it's followed by the 8. So 8 pushes the 9. The 9 is at the limit, so it pushes the other 9. Actually, let me write it down what I mean here. So I know the area is 129.998. Okay, so we said the 8, the third decimal place is big, so it pushes the 9. Because the 9 is at the limit, right? It cannot become a 10 because otherwise it reduces. The 9 is at the limit, so it pushes the previous 9, the previous number. This number is at the limit, so it pushes the previous number. This 9 is at the limit, so it pushes the previous number. So that means that the 2 is going to become a 3. So it's going to become 130.00. I wrote it with 2 decimal places. Now, if you call it 130, because 0.00, you don't have to write it in this case. If you call it 130, that's okay. So for rectangles, you gotta find the two lengths, length and width, and gotta multiply them. Now let's move on to triangles. Find the area of the triangle in square units. Round your answer to the hundredths place if necessary. So let's remember, how do we get the area of a triangle? So a triangle, I have to look for the 90-degree angle. We can call one side length and the other side width. For triangle, I know if I multiplied length times width, that gives me a whole rectangle. And if I imagine the whole length times width, gives me this whole rectangle. But a triangle is half of a rectangle, so we learned that we had to divide this by 2 because a triangle is half of a rectangle. So I had to find the two measurements across a 90 degrees. I multiply them, and then my result is the half of that. Okay, so what does that mean on our picture here? I see my 90-degree angle is there. I had to find this side, and then I had to find this other side. I have to find the two angles that cross on 90 degrees. All right, so for my short side, let me get the coordinates of my points. The coordinates of I are 3, 3. The coordinates of H are 6, -3. I know I'm going to use the point G as well, so let me already figure it out. The coordinates of G are negative 12, negative 12. All right, so for the small side, and I have to do a square root. What's the distance? What's the difference if I was to subtract my x's? I'm not going to write the whole formula. Actually, let's learn how to use it. If I was to subtract my x's, I have a 3 and a 6. If I was to subtract them, don't mind if you go 3 minus 6 or 6 minus 3, whichever way you want. If you were to subtract them, we will get the difference is 3, right? 3, and I'm going to write it as square. Now, if you went 3 minus 6, you get a negative 3. But remember how we're going to square everything? We're going to make it possible. So we just call it 3. Now, plus, what's the distance of the y's? So look at your y's. One of them is positive 3. The other one is negative 3. If you were to subtract them, what's 3 minus a negative 3? 6, right? So this is 6 squared. If you were to type this on our calculator, I'm going to type it on our calculator. So let's see. The square root of 3 squared plus 6 squared. It's about 6. Let me go 4 decimal places. 6.7082. So this length, this short side is 6.7082. Some of you might be like, why are we doing decimals, Mr. Leonzo? Because that's real life. In real life, you don't deal with just whole numbers. You deal with decimals. So we're going to make this a little realistic. Let's take a look at the long side, the distance between G and H. So first of all, I look at my x's, negative 12 and, positive 6. If I was to subtract them, so in my mind, I have 6 minus a negative 12. I know two negative signs make a plus sign, so it's the distance between 6 and negative 12 is 18. So I'm going to call this 18 squared plus. Now, what's the distance between negative 3 and negative 12? I'm subtracting the y's now. Well, that should be 9, right? 9 squared. Some of you might be thinking, how did he get the 9? I went negative 3 minus a negative 12. These two negative signs became a plus sign, so negative 3 plus 12 is 9. All right, so 18 squared plus 9 squared, all of it inside the square root. 18 squared plus 9 squared. I want to go to 4 decimal places, so 20.1246. 20.1246. Okay, so I had to multiply these two numbers. So remember, for the area of the rectangle, I have to go 6.7082 times 20.1246, and all of this divided by 2. Okay, let's grab our calculator here. Let me write a fraction because that's how I'm gonna do the division. So I'm gonna go 6.7082 times 20.1246, and at the bottom I'm gonna write a 2. So make sure you have what you need. Okay, press enter. So I have to run it to 2 decimal places, right? So 67.4999. Okay, so there's some running again. So I know I get 67.499. This third decimal place is big enough, so it pushes the previous number. The 9 is at the limit, it cannot be pushed, so the 9 pushes the previous number. So the 4 is going to become a 5. So I'm going to have this as 67.50. I'm writing it with two decimal places. If you guys only write 67.5 because you guys are ignoring the last zero, it's okay. 67.50 or 67.5, it numerically speaking, it's the same thing. So 67.5 or 67.50. Okay, not bad. Now trapezoids. Find the area of the trapezoid in square units. Round your answer to the hundredths place if necessary. Trapezoid. Let's remember how to get the area of a trapezoid. So we have what we called bases. These are two sides that are parallel. Let me call one of them base 1 and base 2. And then the other sides are not parallel. And then there's a 90-degree symbol somewhere. Sometimes it is somewhere inside the picture. In our case, it is going to be right on the edge of the picture. So it creates a 90-degree symbol. And then this distance between the bases, so that distance that makes a 90-degree angle, we usually call it, I'm going to call it H for height. So for trapezoids, we need to figure out two bases and the height. And what's the formula for this? It's going to be base 1 plus base 2. So we have to add the bases. Notice I'm putting inside parentheses because I have to add the bases. Whatever I get, I have to multiply it by the height. And all of this, I have to divide it by 2. That's a formula for the area of a trapezoid. Like I said, you guys learned this before years ago. So I'm just giving you guys a formula and then letting you guys know how we're going to use it. So let's take a look. Let me highlight in red. These are my two bases, two that are parallel. So the coordinates of P, I guess I'm gonna need all 4 points, right? The coordinates of P are 2, 0. The coordinates of O are 5, -2. The coordinates of M are -5, -4. And the coordinates of N are 1, -8. Okay, so let me get the short distance, the short base. What's the distance? What's the difference between 5 and 2? If I was to subtract 5 and 2, what do I get? Well, I get 3, right? So let me call this 3 squared plus. If I was to subtract the y's, what do I get? If I was to subtract 0 and a -2. So think of 0 minus a -2. The distance between those is 2, right? So it's going to be the square root of 3 squared plus 2 squared. I'm not going to show you guys on my calculator, but I am typing it on my calculator and it says this is about 3.6055. Okay, let's take a look at the older base. Let's take a look at the other base. So first, let me subtract. What's the distance between -5 and 1? Well, the distance is going to be 6, right? If I was to subtract those. What's the distance between -4 and -8? 4, right? So I have the square root of 6 squared plus 4 squared. According to my calculator, is 7.2111. Good. Let me let me specify those are the bases. Remember how I need to know two bases. Okay, those are the bases. Let me write in blue the height, that's the distance between the bases. So that's basically this length. Okay. Looking at the x values, 5 and 1. So I'm looking at these 2 points, right? What's the distance between 5 and 1? Well, that's 4. Right? Yeah, 4 squared. Now, what's the distance between -2 and -8? Distance between the y's? 6. Okay. The square root of 4 squared plus 6 squared is going to be 7.2111. Okay. So I'm ready. I'm going to go open parentheses. I'm going to add the two bases. So 7.2111 plus 3.6055. I multiply this by the height. So in this case, 7.2111. Don't think I used the same number twice. It's actually came out to be the same value, but one of them is the base, the one in red is the base, the one in blue is the height. And all of this divided by 2. I type it on my calculator. I'm not going to show it on the screen, but I'm going to type it on my calculator. This gives me 38.999. I look at 3 decimal places even though it asks for 2 because I do use the third decimal place. Because this 9 is big, I'm going to push the previous number up. Because this 9 is at the limit, it's going to push the previous number up. Because this 9 is at the limit, it's going to push the previous number up. So that means that 8 is going to become 9. So I'm going to call this 39 point, and then those 9s became zeros. So 39.00. If you guys just write it as 39, that's fine. Lastly, for today, let's take a look at number 4. It says find the area of the trapezoid in square units. Round your answer to the hundredths place if necessary. We just talked about trapezoids, so we have a similar example of what we just did. So by 2 bases, I'm going to highlight them in red. So the coordinates of H are 6, 4. Actually, let me write all this in black. So 6, 4. The coordinates of G are 11, 2. The coordinates of E are -3, -4. And the coordinates of F are 7, -8. Okay. So let me get our distance formula here. So I know I have to do a square root. The distance between the x's. If I was to subtract 11 and 6, I get 5, right? So I'm going to write 5 squared plus the difference of the y's. If I was to subtract 4 and 2, if I was to subtract the y's, I get 2 squared. Now, the square root of 5 squared plus 2 squared is about 5.3851. Let's take a look at the other base. So it's a big square root, okay? If I was to subtract the x's, so that's -3 and a 7. The distance between them is 10, right? So 10 squared. Plus, if I was to subtract the y's, so I have a -4 and a -8. The distance between them is 4. Now the square root of 10 squared plus 4 squared happens to be 10.7703. And I need the height now, which happens to be this right here. So I have to write a big square root. Now looking at the x's, 11 and 7. If I was to subtract the x's, 11 minus 7, I get 4 squared. If I was to subtract the y's, 2 minus a negative 8, I get 10. So 10 squared. The square root of 4 squared plus 10 squared happens to be 10.7703. Okay, so I'm ready. So I have to add the bases first. So open parentheses. So that way the calculator knows that it has to do addition first. So 10.7703 plus 5.3851, close parentheses. So I added the bases. I'm going to multiply this by the height. So times 10.7703. And all of this divided by 2. Okay. According to my calculator, I get 86.999. So this 9 is big enough. It pushes the previous number. This 9 is at the limit, so it pushes the previous number. This 9 is at the limit, so it pushes the previous number. So the 6 is going to become 7. So I get 87.00. If you guys call it 87.00 or just 87, you guys are fine.